dealing with a situation during COVID where predominantly we had misinformation, individuals trying to spread information not accurate. We also had the start of deliberate efforts to produce disinformation. And this disinformation is different as it started changing, because it became the basis for polarization in society. It has made our society more polemic. It has pushed people to extremes. You are forced to take a position when somebody sends you something on social media. But all of that changed. It changed at the end of 2024. In that we no longer had this kind of misinformation by, Denzel or Karen or Tandy. What we now are dealing with is a new kind of disinformation. One I refer to as institutionalized disinformation. Where now, in the past, when something was put out and it was incorrect information, you would go to a government website or a reliable scientific website and you would establish what the truth is. In fact, during COVID, the South African government set up a website specifically for that purpose, and I provided information for it. Now you got the problem that the government itself is distributing the disinformation. And Trump is doing so, not just in Trump version 1, but also in his second term. And social media has become now a much more relied on source for information and news. And the problem with it is that there's no editorial checking, there's no fact checking, or not enough fact checking. So misinformation and disinformation can spread very quickly. In fact, it was very interesting when Alex Pretty was assassinated by or shot by ICE agents in Minneapolis. The first information that went out was that he had a gun and was about to shoot the ICE agents, and that's why they shot him. When you saw the video that was put out, then you realize actually they'd already taken the gun away from him. He didn't even have the gun on him when he was shot. And he was already on the ground with 3 people on him when he was shot. So the state is now becoming the source of incorrect information. So the question is why? Why would you want to spread misinformation? Well, all tyrants need to spread disinformation, and they do so for 2 reasons. One is because they are accumulating wealth. They are using their positions to accumulate wealth. Whether we want to look at it from President Jacob Zuma, who basically used his presidency to accumulate wealth for himself and the Guptas, or whether it's in the US. But basically, they're using their positions of power and authority to get rich. How rich? Well, the New York Times just published this last week, where they looked at an analysis of all the monies and the deals he's been making as a result of his presidency, mainly through cryptocurrency and through foreign business deals. And he's making a lot of money. $1.4 billion was their estimate from this article. And there's just a complete blurring of the lines between what is public service and private gain. But if you want to gain wealth, you can't go around telling everybody that. And you can't have others going around telling everybody that. You have to hide it. And so one of the things you have to do when you accumulate wealth is you have to accumulate power. It goes hand in hand. If you're growing your wealth, you have to grow your power. And that power is important because if you don't have it, people are going to find out, or they're going to put you in jail. And you saw that, just look at, in the Zondo report, the very clear way in which Zuma protected himself. As soon as the stealing started, he had to change 3 people. He knew he had to do that. He had to change who the national prosecutor was, so he appointed Sean Abrams. So he knew he got his Sean the sheep there, who won't prosecute him. He knew he had to change the head of the Scorpions, so he appointed Burning Tameza, who would ensure that there was no investigation of Trump or the Guptas. And he had to change the head of the tax service. He had to change the head of SARS, so he put Tom Moyane there. So he put 3 people who could come after him, because they would figure out that he's got all this additional wealth. Well, it's no different in the US. It's no different in any other situation, that you have to accumulate power. And in this particular case, the US government is using a very powerful mechanism of these executive authority declarations. And so what's being done? Well, it's converting the country, according to The Economist, to a welcome to anything goes America. Right? They've reduced tax auditing. They've reduced the prosecution of politicians for corruption. They've gutted the Public Integrity Unit, and they are pardoning donors and relatives. So all you have to do is give a bit of money to the Trump campaign, and you get a pardon. As you've already seen, that's now happened several times. So, when you accumulate power and you accumulate wealth, they go hand in hand. But your big problem is that there's this pesky thing called elections. And that might land you up with a situation where you're no longer in power. So here are 3 individuals. I've just used these 3 as an example. They are all individuals that hold high-profile positions. Heather Honey, who is now in charge of election integrity. Marcy McCarthy is the director of cybersecurity and infrastructure security. And Cleta Mitchell, who is the lawyer in the White House dealing with election-related cases. All 3 of them were election deniers. They were all involved in promoting this notion that Biden won because he stole the election, that the elections were rigged, that Trump lost it because the elections were crooked, not because he actually lost the elections. And what he's done now, they are now in charge of the next election. So you've got to figure out a way to keep yourself in power. Just look at Zimbabwe, how well they figured it out, how to keep yourself in power. And the essential element in gaining and protecting this wealth is to hide that truth. And to hide that truth, you have to put out false claims, all kinds of false claims, because you can't allow the truth to be out there. So looking at all of these false claims, your big problem becomes truth sayers. That as you accumulate wealth, as you accumulate power, and you have to hide the truth becomes more than inconvenient. And so there are 3 primary targets who are truth sayers. The first is the free press. The second is the legal system, the independence of our courts. And the third is our universities, our intellectuals, our scientists. The truth becomes the enemy, and those who are the truth sayers become the enemy. And so when we look at what has been done in the US, there's been a whole lot of lawfare against the media, suing the New York Times, as basically suing anybody, and gut independent radio, independent television. And that's basically what was done. In the US, the legal system, one of the first groups the government went after the Trump administration was lawyers, the legal firms of the Democratic Party. Got them all to agree that if he didn't, that he would not sign executive orders against them if they gave free legal advice and free legal services to the organizations he chooses. But let me touch on scientists, you, sitting in this room. That we saw how in the US Columbia University was a very early target and how it capitulated. Whereas Harvard University stood its ground, took the administration to court, and won at least the first round in the courts. So how do we know that scientists matter? We know scientists matter because of a chap called Anthony Fauci. Trump used all the might of the state to go after Tony Fauci. Why? Because Fauci continually contradicted the president on COVID-19, on anything relating to science of infectious diseases. And so he became target number one. That tells you the power of a scientist, that to put the truth out there, how inconvenient it was and how powerful it can be. And so I want to end off on that note. The power of information for the truth is needed now more than ever. The history of science, no matter which of the ages you look at, it has been our search for the truth. And there is a truth. We spend our lives searching for it, arriving at it, testing it, challenging it, till we're happy that it's the truth. That remains for us our main weapon, that we have spent our lives searching for that data, searching for that information, arriving from it. Because information is power, and disinformation is the abuse of that power. So, disinformation, what should we do? Let me end off on this note. And here I'm quoting from a chapter from my own book, so excuse the self-quotation here. That it's very important to recognize and understand the problem. You have to study it. You have to collect the data on it. You need to know what you're dealing with. You have to appreciate the role of scientists, as Truth says. You hold power. Each one of you as scientists, you are powerful people because you are the purveyors of truth. You make it your job to search for the truth. That you should always continue to fact check what you read and see, especially when it comes now even from government. And that we need to support the free press, the independent press. And we need to rebuild that trust in science. We've got to communicate science. We've got to promote the public understanding of science. We've got to get them to come across again to believe that we can find the truth and we can find solutions to the world. And every bit of resistance, no matter how big, how small, every bit of resistance counts, even when it seems not significant. I wish you well as you take on the pandemic of information, of disinformation. And I know that all of you sitting here are powerful people who will continue to purvey the truth. Thank you very much. And as my last act, I'm going to hand to Professor Dorrington a copy of my book, which I have personally inscribed to her. And so I'm going to ask her to please come over to accept a copy of my book, Standing Up for Science, because that's what she does.
It's not often that I'm speechless. In exchange for something far more valuable, I have a small gift for Professor Abdul Karim. I'm really sorry. This is an alcoholic gift, and I know that Slim doesn't drink alcohol, but he's assured me that somewhere at home there will be a celebration where somebody will be able to enjoy it. Thank you. Thank you. We are out of time, but I think we all have a great deal to think about. And I am incredibly grateful that Professor Abdul Karim didn't say no when I phoned him and asked if he could do this. Thank you. Thank you. Thank you.
check 1 2, mic check 1 2 1 2, check 1 2 1 2, check 1 2, mic check 1 2 1 2, check 1 2, check 1 2, mic check 1 2 1 2, check 1 2, check 1 2 1 2, mic check 1 2 1 2, check 1 2 1 2 1 2. Check 1 2 1 2, check 1 2 1 2, mic check 1 2 1 2, check 1 2, mic check 1 2 1 2, checking mic for the stream, mic check 1 2 1 2.
push down? It doesn't matter. Any arrow.
No, so push right, yeah?
Okay. Right, it's not showing right now, no.
No. So,
Okay.
and then, so when you begin, you can just push over to that.
Okay. So then when it comes to when Karen's finished, then Rachel's name will come out. And when she comes up,
The
I will.
screen will come
come
up
up.
when Karen's finished.
Okay.
And then you
I
can
can-
introduce
Well, I'll
Rachel.
just say now we move on to the next speaker. Okay.
And then Rachel can move on to her presentation.
Okay. So what have I done now?
It's okay.
Okay.
So you just, or would you like me to come up and just put it onto that side and then you can,
No, that's fine. I can do
are you happy to do it? Okay,
Yeah.
so it's just that part there.
Yeah. So what I'll do is I'll say my little spiel first, and then I'll say, so now Professor Yarkop's coming up, and I'll. And then, yeah.
Thank you.
Can we settle down, please? Okay, thank you. Good evening, everyone, and welcome to the Bio26 Sunset Lecture. We are delighted to have you with us here in person and to welcome those joining us from the live stream, and that could be somebody from across South Africa or maybe even internationally, so welcome. I'm Professor Joe Damas, the Dean of Science here at Rhodes University. The Sunset Lecture is a very special event here at the Bio26. It is where the science steps out from behind the conference hall and into a public space, where research meets lived experiences and where conversations about synergies, symbiosis, and sustainability are grounded in the realities of soil, water, food, and human well-being. This evening's lecture brings together two outstanding scientists whose work spans different ecosystems, from the soil beneath our feet to the water that sustains our communities, yet is still united in a shared message that healthy environments depend on collaboration, connection, and respect for the unseen microbial and human networks that sustain life. It is a pleasure to introduce you first to Professor Karen Jacobs, Professor of Microbiology at Stellenbosch University. Professor Jacobs is a leading microbial ecologist whose work has been instrumental in advancing our understanding of soil microbiomes, fungal ecology, and plant microbe interactions, particularly within agricultural systems in South Africa and the global south. Her research shows how microbial communities underpin soil health, crop productivity, and ecosystem resilience at a time when rising input costs, climate pressure, and soil degradation are reshaping how we think about food production. Beyond her scientific contributions, she is deeply committed to postgraduate training and research capacity development, helping to grow the next generation of scientists who will steward our soils and ecosystems into the future. Joining her is Dr. Rachel Sippler, Senior Research Scientist and Director of the Center for Water Health and Humans at the Bigelow Laboratory for Ocean Sciences in the United States. Dr. Sippler is an internationally recognized marine biogeochemist whose work explores many microbial processes, water quality, and environmental change intersecting together to affect both ecosystems and human health. Through collaborative research conducted in diverse settings, from urban rivers and wastewater systems to polar oceans, she works closely with communities, indigenous nations, governments, and industrial partners to address pressing water challenges such as pollution, harmful algal blooms, and nutrient imbalance. Her work exemplifies science as a shared endeavor, rooted in partnership and action. Together this evening, Prof. Jacobs and Dr. Sippler will guide us through two interconnected perspectives. In The Living Soil, Why Microbes Matter, we're invited to rethink soil not as just grains of sand, but as a living system shared by microbial life that holds the key to sustainable agriculture. In Working Together for Healthy Water, Lessons from Community Partnerships, we will hear how communities and scientists can co-create solutions to protect water resources and build healthy futures. As the sun sets, this lecture reminds us that sustainability is not only a scientific challenge, but a collective one, requiring cooperation across disciplines, ecosystems, and communities. Please join me in welcoming our Sunset Lecture speakers, Professor Karen Jacobs and Dr. Rachel Sippler. Professor Jacobs will start off with her talk.
Good evening, everybody. It is really, really nice to be here. It's a great honor to be invited to do this lecture, and I hope that I can convince some of you that our soils are critical to survival in South Africa. And as Joe has mentioned, most of my work is in agriculture, where we try and help our regenerative agricultural farmers to move into a more sustainable type of agriculture while they minimize inputs. So I'm going to talk a little bit about that. But let's think about our close relationship with the microbes that we have. We all know that we have microbes, we have microbiologists, we have microbes all over us. And the latest paper suggests that there's about 39 trillion microbial cells. And these are unique to each person. And we know this, we know how to take care of our microbiome, we know what we eat influences what this thing looks like, and the microbiome influences what we do, how we feel, and sometimes how we think. And if you take all of your microbes and let's try this again. You lie them in one straight line, it is going to be about 4,000 kilometers of microbial cells, which is quite a bit. So what do? They protect us from pathogens, which is really important. They aid in metabolism, help you digest your food, and also they mediate our immune systems, and they are critical to that. So usually when I speak to people who are not microbiologists, they immediately want to go and take a bath and get rid of all of these microbes, but don't do that because they are so critical to your health. If you think about plants, it's exactly the same thing. All plants have microorganisms associated with them from the tip of their leaves down to their roots. And these things play a critical part into the health of the plant as well as the environment. And I just did a word figure here with all of the species of bacteria that's ever been associated with plants and soils in agriculture, and it's quite a number of them. And the same with fungi. There's a lot of different species and genera associated with soils and with healthy plants. And if we look at the plant microbe actions, and that's where I usually say let's now focus into where it really matters. It's in the rhizosphere of our roots. That's where all the action takes place. This is where you need to know what is going on in your microbiome in order to understand whether your plant is healthy and get all of its food. And these can be direct or indirect interactions. Direct interactions is some of these organisms can fix nitrogen. Nutrient mobilization. Without them, there's not going to be coming nutrients into your plants. And there's also some indirect interactions as well. But what is really, really important is many of the functions of the microorganisms in our soils are still unclear. But what we do know is they do not function as individuals, and this is where I really liked your talk last night. They don't function as individuals, they function as consortia. And we have to think about that complexity. And I always tell the farmers, lean into the complexity and just embrace that and understand you can't just pull one thread and think things will work out. So very interesting is that about 10 to 40% of the photosynthetic product that we have get excluded or exuded through the roots as root exudates. And those things are really important because what do they look like? They're amino acids, all kinds of other sugars and proteins. And this is my attempt at animation. Through a process called chemotaxis, we have bacteria being pulled into this rhizosphere and connect to the plant root. So there's a very distinct chemical signal between plant roots and microorganisms. And what we found is that that is so distinct that each plant has its own unique microbiome. We do continue routinely, we do analysis for farmers, and my technician is so good at this point. If you tell her, you don't have to tell her what crop it is, she will tell you what plant you plant just based on the microbiome analysis that she does. She also tells you whether you do chemical farming or inorganic or organic farming. So how do we study these things? For those of you who don't know, we used to just look through the microscope and think about just the individuals that we see. And with the new technologies that has come forward, the high-throughput sequencing, metagenomics, we have various ways to study these things. And the way we see it, and people have different interpretations. And I think the challenge now is trying to bring all of this together and understand these communities. So we always are looking for the invisible. And it truly is the invisible. So when I talk to the farmers, I always tell them, do you know how many cells you have in a gram of soil? It's about 10 trillion cells per gram of soil. Think how many grams of soils you have on your farm. We know that fungi is about 30% of that biomass. It's crucial in keeping the soils together, making aggregates in order to make nice little microhabitats for these organisms to grow. One thing that is a little bit debated is the definition for soil health. And we're going to stick with the USDA definition, because I think it makes sense, which tells us that soil is referred as a soil quality is defined as the capacity of the soil to do something. So whether that is to grow the crop or anything else, as long as it's functional. So we're trying to ask people not to talk about soil health, because that is kind of very, very difficult definition, but talk about soil functionality. In other words, the question should be, is my soil functional for what I try to do? In South Africa, we've seen an 80% increase in the cost of fertilizers. And I don't have to tell you what the impact is. We all see that when you go out and you buy food. It's not so profitable to farm these days. Most of our chemicals are imported, so whenever the dollar and the rand plays off against each other, we feel it in our pockets. So the area that I work in is regenerative agriculture. Regenerative agriculture is a way of farming in which they reduce tilling on their farms, in other words, preserve microbial communities. They have different practices, which includes cover crops, in which they say or the claim is that they increase microbial diversity, using compost, increase organic matter, then go into biopesticides or biofertilizers instead of the chemical fertilizers, and some of them even introduced high-density grazing. Now, this is by no means a way of just let things go and hope for the best. This is a highly managed system, and I'm going to try and explain it a little bit. So, for instance, say you have a monocrop. You remember I told you that each crop has its own unique microbiome. If you harvest this and you till it, you lose that microbiome, all those microorganisms. If you put in crop rotation, you don't usually do tillage. So what these guys do is they take off the crop, and then they would plant the next one in between those living roots. So you already have a living system in there, and your seeds goes in there. So immediately they grow so much better. They have access to food. They have access to a source of microbes that they can pull from. So as your crop grows, you enlarge this microbiome. You can go as far and add more plants. The more plants you have, the more diverse this microbiome becomes. And this is something we've seen again and again and again, is when people want to increase the diversity of microorganisms, increase the diversity of your plants. And if you really want to go to the extreme, get some animals into your system. And the big thing that they do is they put down urea, they put down water, and I was actually amazed to hear how much water a herd of cattle can put down in the field. Really important in a country like South Africa, where we are water scarce. And then, of course, composting is there. You know, the poo that goes down, it brings other microbes, dead microbial matter, as well as nitrogen, phosphorus, and carbon. For those of you who don't know, most of our farms are farmed on marginal soils. They just look really nice when we go past them, but most of our soils are struggling to get to 2% of carbon in the soils, which is pretty low. Yet, our farmers are able to feed everybody in this country. So just to go back to this, so this is an example of some analysis that we did. So each of these dots is a soil sample, and each color represents a crop. And this is where we figured out, oh, look at that. Each crop has its own microbiome. So when you want to take this, the academic information, and you go to a farmer, we have to be able to measure it. So because if you can measure this stuff, you can manage it. And that's what it is all about. So we want to measure it, translate it into a language that people can use to manage the crops. So I'm going to share just one case study with you, and I hope that you can see. So this is a PhD student. We worked on maize in the Free State, which is lovely. And we compared regenerative farming with high-intensity grazing with conventional farms. The first thing we notice is that, you see, oh, that's very light. But you have to believe me on this. The first thing we notice is that conventional farms have much lower diversity than conservation farms. You can not just see this in the microbes, you can also see it in the plants that they have. One of these farmers showed us a spot on his farm where he was able to, there was grasses growing there that I haven't seen in the last 60 years. So he created an environment where these things can grow. So that's a little lower. We see higher there. Very important, we see very distinct communities. So the yellow one is the conventional one, the red one is conventional, the yellow one is the conservation farm. And they have very distinct communities. And what's really interesting is that these two farms are separated by one road. So they're very similar in terms of the soil microbiology. We went further and said that what is the effect of this type of farming on, for instance, nitrogen? In South Africa, nitrogen is an expensive thing. We have to put it into the soil and we have to buy it. So what can we do to encourage the local microbiomes to fix nitrogen and bring it into the crop without adding? So can we reduce nitrogen input? And for this, we looked at the nitrogen cycle. And this, I know you cannot see very well, but those are the key enzymes that we looked at. For clarity, the yellow is the conventional farm, the green are all the regenerative farms. The first thing that we saw is that all of the enzymes in the nitrogen cycle do so much, there's so much more expression when you have regenerative farmers. Reduce nitrogen inputs, the chemical nitrogen, and increase other practices. What is really, really interesting, and in some of these enzymes you get complete suppression. So the MOA pathway, for instance, is where where nitrogen is mineralized to go into the plant system. That gets completely shut down when you use chemical fertilizer in your systems. We went even further and we saw the same thing, and again, I apologize for very small slides, but we looked at more areas across that maize growing region, and we kept seeing the same thing, is that regenerative agricultural practices are doing so much better in terms of microbial diversity as well as the functionality of those soils compared to conventional farming. So what does that mean? I'm going to end with this. It's a very, very recent paper. We're all concerned about climate change, and in South Africa we are particularly concerned about it because we try and grow our crops on marginal soils. We know that temperatures are going to go up, which means a loss of water. With regenerative practices, you can conserve water in your soils and you bring your temperature down. And some of our Australian colleagues have showed that you can bring the temperature down by about 10 degrees in the summer. There's a big difference between 40-degree soils and 30-degree soils. So there are different things that can happen, scenarios, but what these guys found is that if you combine them, the outcome is so much worse. So we shouldn't just look at warming or reduced moisture. The combination of these different factors will lead to a much worse outcome. And regenerative agriculture is just one way in which we can alleviate that and still manage to grow crops and feed our nation. With that, I'm going to leave you with this quote from my colleague, who says that soil health, like beauty, is in the eye of the beholder. With that, thank you very much. I hope Did I stick to 20 minutes? Can I ask one question?
We do have some time for questions. There is a roving mic if you put up your hand and if you'd like to ask a question. Has anybody got questions? I can see nothing with the light in my eyes.
There's a question.
There's a question. Is there a roving mic up there?
Hi, Prof. Thanks for the presentation. It was very insightful. Can you maybe expand on the regenerative farm that you saw in the Free State? How would that look in practice? Because it sounds really cool.
So in practice, I'm happy that I have a couple of things. So regenerative farms in practice takes a while. It takes about 10 to 15 years to get it up and running to a point where it is profitable. So what this particular group of farmers do is they've stopped doing tillage and they start introducing crop rotations. But when they harvest the crop, they don't remove the rests in the field. So they plant the next crop into those rests. So immediately you have cover that covers the soil. You do not lose your topsoils, because in the Free State, you know, those winds comes through, it removes all of the topsoils. I always tell the farmers there, you don't have to inoculate your soils, just wait for August, and your neighbor will inoculate your soils for you. So they don't lose the topsoil, they have lower temperatures and higher moisture. So then they have the soil crop rotation. So some of the farmers start with wheat, sunflower, and then they have something like lucerne in there, depending on the nitrogen. They also have high intensity grazing, which means that this particular farm that we visited, they would graze a herd of about 100 animals for 45 minutes in a strip, and then they move them. So what that does is that the cattle eat selectively, so they don't eat everything down to the ground, so they leave a lot of plants in the field, and it recovers very quickly. So that's one thing, and the intensity grazing is with cattle, sheep, and chickens. So they have these portable chicken coops that they pull around the farm, and you can smell the soils when they pull that thing over the soil. When they pull it away, the soil just smells differently. It's very, very organic. So this particular farmer has been working on this for the last 15 years. He's refusing to spray any chemicals, so he used some nitrogen fertilizer when needed. So he does spot applications, but he has no other fertilizer. He does not use fungicides, and he uses no antibiotics on his animals. So he also sells meat from his farm. Here's one example of a farmer that does it really well. Down in the Cape, we do it a little differently. So there, we're trying to plant vineyard in rock. So what they do is they dig a hole, they fill it with compost, they put the little vine in there, and they leave it. So over a couple of years, the cover crops breaks down these rocks into something that's usable as a soil. So I think one of the sites that we do annual analysis for him, it's been running for 5 years. It's completely covered with a cover crop. It's green, green, green underneath his vines. His carbon is way better than his neighbors. His soil is functional, so all his enzymes are functional in those soils, and he has really good diversity, but no tillage, and he keeps his cover crops. And that's one of the other principles these farmers have is 364 days a year, they have green on the field, so they never have fallow fields. And then you would have to, when they have no crops or grazing, they let it sit for about 7 months to recover, and then they start the cycle again. So you can see this is a really, really well-managed project. And then the other thing that is really good is they were able to clean up the water systems. So the dams look better because they don't have a runoff of nitrogen into the water systems there. So they have nice, clear water there, which is a side effect that nobody saw coming, which is good. Okay, any other questions? Nope. Yes, done.
Any other questions?
Yep, one more question.
I have one more question. I know in Stellenbosch there by Spear there is Farmer Angus. I think he does regeneration as well. Is there a study linking soil health and the microbiome of the soil to the nutritional information of the food and the animals? Is there a study like that?
That's an excellent question. We are going to do that this year. So we're setting up a trial in the Free State on this particular farm where we know the farmer is not using antibiotics. So we've, maybe I'm a little biased, but his meat tastes different than Pick and Pay meats. Very, very different. It looks different. It actually looks like proper meat. So they currently sell beef and chicken. The chicken does not shrink when you put it into the pan. So we have kind of a feeling that the crop would be better. So the nutrition, so we have somebody that's going to look into the nutritional value of the crops that comes off his field. But I think my gut feeling tells me that it is better, even if you can just reduce all of the chemical residues that's currently on our crops. That's already a win. Thank you very much.
Thank you.
Thank you very much. Ooh, this is for
Well, thank you for that, Corin. And now I will call up Rachel to give her talk. And there we go. There. Is that right? Yes. Go for it.
Great. Thank you all for having me here, and thank you for coming. Wow, that is pretty bright. So let me know if I'm staring somewhere. So the work today I'm going to talk about is working together for healthy waters. And I'm going to focus less on my science and more how we use our science to support communities to reach their goals. I come from the US, as we said, from Bigelow Laboratory for Ocean Science. Bigelow Laboratory was built from a group of international scientists who joined together to do one thing in common. They wanted to do work that would improve the life of all organisms on this planet. To do that, a group of us have joined together to do something called Water Health in Humans. And that means that we're trying to do things that directly impact people on a direct level, something that you can see a change really quickly. While other research may be long-term goals of building biotechnology that can improve the planet, we also want to see the individuals in our work. Science that is with and for our communities. So when I say the word we, I don't do all of this myself. These are just some of my colleagues that we work with, plus our students and technicians and all kinds of support, including the communities that we work with. But I'm the center director. We have Christoph Apley, and he does a lot of the pollutant work, leads that. Peter Countway and Robin Sleeth. They work with microbial communities to understand where toxins may be coming from, what microbes may be in drinking water that we need to remediate, and just other techniques that allow us to see what fish are there. And then Steve Archer, and he's does a lot of the chemicals, so toxins that might be in your water from biological sources. So as a group, we believe that thriving communities, ecosystems, and economies start with healthy water. So every part of our lives is shaped by water, whether we realize it or not, although you can tell it. So one is that water determines where we live, what we eat, our health, and whether communities thrive or struggle. But the water that runs off in the streets that we saw yesterday from that beautiful storm, it's not just water. Runoff has a little bit of everything that water touched. These natural and also man-made compounds run off into our systems, and eventually through the system of how water travels, it can make it into our drinking water, it can make it into our lakes, our streams, and eventually into the ocean. Runoff from farms can carry, as we said, fertilizers, pesticides, herbicides. Runoff from urban sources can carry things like microplastics and something called forever chemicals. So forever chemicals are per and poly fluorinated compounds that we call PFAS. That's been in the news quite a bit. Those are just some of the examples of things that come off of our roadways, including oils. So residential runoff contains all of these things, including cleaning products, pharmaceuticals, gasoline from cars and gas stations, the number of plastic particles that are coming off. I think we see the plastic bottles and the bags, but microplastics are an emerging and pretty serious pollutants that's coming into our systems and has been for a long time. So some of the threats for water quality include biological threats. We know that bacteria can be an issue, viruses, protozoa, also algae. We think of algae, there's blue-green algae, which is technically a bacteria, but it makes your water look like it's completely green and slimy, so unattractive to drink. A lot of those blue-green algae can also clog up the gills of fish, or some of them produce toxins that can impact people. There are chemicals, including heavy metals, pesticides, those pharmaceuticals, and synthetic chemicals. And physical changes like sediments, cloudiness, salinity, and then just taste and odor. If you ever had thought, like, oh, this is a beautiful clear glass of water, and then you get it up to your mouth and you're like, not so great, right? Not as tasty as I was hoping it would be. So safe water depends on the entire system, from source to tap. No single test result gives you the whole story. You can say that, oh, our water is clean for bacteria, or it's clean for a specific chemical or for a specific nutrient, but it's the suite of all of those parameters that tell you the full story of what the water has experienced in the past and what you're putting into your system today. Water treatment plants, while they get a pretty dirty rap, they reduced risk dramatically, right? If a wastewater treatment plant is working effectively, you should be able to drink the water coming out of that plant. It should be that clean. But the problem is that we are continually evolving the chemicals that we are making to go into these systems. Their pharmaceuticals are expanding faster than our ability to identify how they're degrading in our systems and what that impact may have in the future. Again, PFAS is a good example of this. These forever chemicals that were brilliant at fighting fires, right? So we use them in cooking, in our household use, to fight fires. We use them everywhere because we didn't understand that the long-term consequence for ourselves and for our ecosystems, we didn't understand what that was 50 years ago. But the problem is that the wastewater treatment plant, because of those factors, doesn't erase everything that humans put into the environment. The most effective solutions when it comes to remediation, whether it's improving your environmental system or your water for drinking, is that it has to work long term, right? There's a societal benefit. One thing I think about climate change is that really affected how we think about it is that it was proposed almost, or at least it was interpreted as almost this all or nothing approach, right? Either you gave up driving your car and all of the resource and all of the things that you thought you needed to help the environment, or it just didn't matter, just keep living your life. And the answer is that it has to be sustainable. There needs to be a social, environmental, and economic benefit to all of it, a balance. Everything has to give, right? There's a little bit of give and a lot of receiving in those processes. For social and environmental, is it bearable? Can you actually make it happen? Can everyone stop driving cars tomorrow? Can we get all of the trucks off the road tomorrow? It's probably not bearable. We can't do it. We have to move our food, we have to move supplies, we have to move people. Environmental and economic, is it viable? Is it so expensive that you can't do it? Or can you find a way around that? Is it equitable? Economic and social, does it benefit one group over another? So working together toward ethical, equitable, and sustainable solutions is key. And we do this by building trust and growing impact, building community partnerships to support ecosystem and human health. Whether there's a lot you can do at your own home to improve the quality of the water that you drink, you can also take action by joining other groups in your community to make a difference. I'm going to give you a couple examples of how different groups have come together or developed even environmental departments of their own to address some of these issues. So everything starts with change, or change starts with observation. What do you see in your environment that isn't working? What do you see of the human impact that needs to be remediated? So working in and with our communities to identify these issues will impact and benefit ecosystem and water health. So people using or engaging with the water sources every day, those people who are witnessing these changes are often the first to identify these early problems with enough time to make a difference, right? Somebody who's like, oh, I see that water is turning green, or I'm starting to see that this water is smelling bad, or I see an oil slick on the top. I wonder where that might be coming from, right? Those small observations while you're taking your dog for a walk or you're driving past it, those observations can mean something. It can mean time, and it can mean opportunity. So we have two examples. One is of a community group that had a lake where there's recreation and tourism, and a lot of people drink from this lake in the summer. Another one is an effort to remove dams that had impacted water quality and fish use and migration and the health of that ecosystem. So I'm going to first talk about Mid-Coast Conservancy. They're partners of ours that came to Bigelow asking what we could do about the greening of that water. They saw the cyanobacteria, those blue-green algae in their lake, and they were worried about the toxicity of those organisms and the impact that it would have on their health and the health of their ecosystem. So what did they do? They committed to enhancing the quality of life in and around that lake. They put in the effort. Groups of people came together, they identified the problem, and then they decided that they were going to start a monitoring program of their own. They were going to ask for help from scientists who had skill sets that they didn't have, and they joined these groups. There's a couple of our researchers are in that boat in the first picture, and they went out with the Mid-Coast Conservancy that formed around this effort, and they began to monitor lake health and to protect the water quality for the long term. This has been a 4 or 5 year project that they're continuing. They had volunteers and employees and people who just came in from the community that would help them collect samples. They came to Bigelow and they trained on the techniques that they couldn't do in their own facilities, and they expanded, they took that knowledge back to their own spaces to be able to start that science in their own communities, to only bring back the necessary samples to run on the very limited equipment, right? So if there's something that Bigelow had that they weren't going to purchase or couldn't afford, then they would come back. But otherwise, they can do a lot of these things on their own to get it started. There's ownership of the benefits to the lake, and there's ownership of that data. Ownership is important, right? Everyone having a piece of the improvement of an ecosystem is important. Knowing that what your hands are doing, what your emotions are doing, what your time is doing to improve it for yourself, your neighbors, your family, and your future is important. So one of those goals in that avenue of thinking is that they want to educate the next generation to care for and protect the waters. So that means that going into their community, telling people, and getting them involved. So they take action. So working together to strengthen ecosystems and the communities that they're in. What could people do? Well, people can dig a trench to help divert the pollutants from going into the lake, right? You can grab a shovel, you can give of your time, you can start to landscape and think of the small actions that have big impact. And then they went back to their communities and they kept telling them, this is what we're doing, this is why we're doing it, this is what we're finding, right? There was constant communication. One thing that we failed to do in science a lot is we wait until we have the answer to tell people about it. And when you're working with a community, there has to be this understanding of the time in the process. It may take years to improve a system. It may take a lot of effort. But when you can show and talk about the little experiences, the little improvements, the little action, people want to get involved. Another group that's building capacity and knowledge are the Passamaquoddy researchers from the Zabayag Environmental Department. Passamaquoddy tribe is part of the Wabanaki Nation in the area that is now called Maine. And they are the protectors and the stewards of their traditional homelands. That is a huge responsibility. They see the land and the rivers as family, as people, really. I should leave it at that, right? These are they're hoping for the rights of the spaces that they use because everything depends. Environmental health, public health are so intricately linked, and they've known this for thousands of years, and they're fighting for those opportunities. If this is a relative and you like your relative, you would not treat your relative the way that we treat our ecosystems. We wouldn't let garbage, we wouldn't let it degrade, we wouldn't try to ignore it for our other priorities. We would try to help them. So we think of these ecosystems as our family and something that we have responsibility to. That's pretty important and pretty impactful, and it changes how you walk through your life. So they're building capacity in their community through hands-on training. When we first started going up to the Passamaquoddy tribe area, we would see on the Schoodic River, we would see 5, 8 students coming along just to see what we were doing and how we did it. And I have never seen students so intent on understanding what the process was. They would take turns, and they learned in a way where they would immediately communicate it to each other because they knew that teaching was so impactful for learning. And you would teach a student, they would all be looking, and then they would describe it to the next student in line whose turn it was, because they wanted to pass that information along. And it was so empowering, and it changed how I do my research. It changed how I see these working with communities and to make an impact, is that teaching aspect. There's something beneficial about telling, but there is something life-changing about teaching it. So they would share what they would learn with their community. And that was important, both through the students that were part of it, but through direct communication. No decision was made by the individual of what was good or bad. It was made by the community and an effort to move forward. The community identified the priorities. The tribe set what the next step was. And they took action. They sought grant funding. They made huge efforts, international. That river is directly on the border with Canada. So they wrote grants, and they had some of these dams removed from their homeland territories. Dams that had choked the passage for fish and nutrients into their rivers, they had those removed. And there is debate around removing dams. What will that happen? What will happen when they do it? Will it release more problems than not? There was paper mills, and there are wastewater treatment plants. What are the impacts? But they decided they were going to do the research. They were going to work with places like Bigelow to actually understand what was happening in that system, so when they removed the dams, they could make recommendations. Is this water safe? Are these fish safe? So we recently, the Passamaquoddy tribe that we worked with them to write a proposal to the Environmental Protection Agency. And with that proposal, it is to look for heavy metals and PFAS in their traditional fish, right? The fish that they have always consumed and that are part of their culture. When we got this proposal funded, it was several years ago, and we weren't sure if we were going to be able to keep it. But I'm really proud to say that when we had to reapply for that funding that we were awarded in the current administration, they agreed that this research was important, and they gave us the money to continue that research. And that tells a lot about what the research that we're trying to do. It's so impactful and so meaningful to our communities that no matter where you come from, no matter what your priorities are, you can see that the work needs to happen for the people to be healthy, and that is where we're moving forward. So as you can see, this is funded to the Passamaquoddy tribe primarily. We are subcontracts, we are supporters in this research. We help them do the analysis, but they are leading the research and they are leading the restoration efforts. It's their research. We use our tools, we use our science to build that up. They define their goals, and we help them achieve their goals. That is how we see this science supporting that. So they're monitoring the health of culturally important fish species before and after dam removal, and we were lucky enough to join this collaboration. We were there the day they let the dam. We were able to see those waters drain from the river and the feeling that those fish could return to their homeland territories, just like the Passamaquoddy people have heard for generations, that they don't have to struggle through fish ladders and they can have a healthy ecosystem, was really important. So they're helping ensure the health of these homeland waters for generations, again, by training new generations and engaging students from middle school, high school, college, and then training people into the positions to be the leaders of the future. Another aspect is stronger together. Their collective action reduces individual burden and increases impact. So one thing that I've done as a representative from Bigelow is I've joined the Clean Drinking Water Initiative, which is part of our region. And this is, again, these are small examples, and I wanted to say not the big global efforts, but these are community-based efforts. We gathered groups together in different organizations from around our region that had shared concerns about water quality, and we joined together to both educate the public and to support each other. And I get to help when there's a question or they don't understand, there might be an issue with our reservoirs. I'm the one they call, and they say, Rachel, can you help? Do you know anyone who can help? And we're able to take our science, the science that I do with nutrients or harmful algal blooms, molecular data, and pull that together to support the needs of the community. And when you have that network, you lean on each other. When you want to understand if it's safe for me to let my daughter swim in the lakes, I know that there's a number of groups that are trying to maintain that health. And one thing that the Clean Drinking Water Initiative is doing, one way to keep our lakes and waters clean is to not over-construct around them. Land use is really important. When we have a lot of housing developments, and in our area we don't have a lot of housing developments in the region, but they're growing. When they grow, try to reserve the area around your reservoirs and your drinking water sources if you can. Rainwater is often chemically clean, but can still be vulnerable to some aspects. The advantages are they're low salts, low heavy metals, independent from failing infrastructure, and generally pretty clean and healthy to drink. But there are a few caveats here and things that you need to think about. One is your roof material, air pollution, if that may affect it, birds and animals maybe contaminating some of those spaces, and then tank cleanliness, whether those tanks are maintained. So what can you do at home? So if you're just one person, what can you do to make sure that your drinking water is clean? So even small actions like filtering your water can have big benefits. Carbon filters, a lot of us use those. That's one major, and I would say the one I recommend the most. They bind and capture contaminants and improve the taste and smell and color of the water. But more importantly, they take a lot of the heavy metals. Some of the lead and mercury come out, disinfection products, the pesticides and herbicides. Again, not everything is caught, but a large portion of them. They're incredibly good at removing PFAS and forever chemicals. They're really efficient. Pharmaceuticals are able to take out some of those. But again, this is an evolving space where some are going to be caught, but it's something that you can do that's quite easy. They have under the sink options, they have whole house filtration systems, and honestly, I won't brand it, but there's a well-known carbon filter pitchers out there that everyone can use for not very much money that you can get at the local store really easily. So it doesn't take a lot of effort to be able to achieve that cleanliness. So why filters work? No electricity required during load shedding or outages. They're low maintenance, so simple cleaning and cartridge replacement. They're effective for the common risks like microbes, chlorine, bad taste, and many of the chemicals that we're concerned about today. They're widely available, again, sold commercially at many price points, so you can find something that you can likely be able to use for a long time. Flexible design, again, those faucets, countertops, under sinks, pitchers, you name it. I even have a water bottle that's got a little carbon filter in it. They're proven and they're trusted, and they've been used for decades for both household use and emergency, so they're really effective. So they also empower households to control their own water safety in that way. So some take-home messages. Clean water is about systems and not sources. Work with your community to improve the conditions. Actions, even small ones, can protect your health. Simple filtration can dramatically reduce risk. And clean water is about layering protection, understanding the risks that are at hand, and using practical tools wisely. And those tools can be the people that you know, your community, your scientists, or a Brita. So I'm hoping that with that talk you are slightly inspired to go out, to join your community groups or start one yourself, to find an issue, whether it be water quality or something else that needs to be improved, because you can make small actions, you can take improvements, and like the Passamaquoddy tribe, you can start to see your fish returning right away, right? You can start to see, if you're the lake, you can start to see the water improving. And for drinking water, you can see that it's going to stay clean for generations because of the efforts that we're putting in today to make sure we don't contaminate it long term. So, thank you. Great. Don't get to leave.
There is still a bit of time for questions. If anybody has any questions, do we have any hands? Nobody? Yes.
I won't worry about the mic. I've got a loud voice. This has obviously been going for a number of years that you've been involved. Can you give us some idea? You spoke about a community where just 5 or 7 students would come along. How has that grown in numbers of people?
So I've only been at my current position for 4 years. So these collaborations, they're not very long term. They're very active, they're very impactful, but they haven't taken very long to show that impact. The students that we had been working with the Zabaic Environmental Department, it's every time we go out, right? These could be students that just come in and they say, oh, we know about your going out, can we join with you? Right? We are growing this opportunity when we come up and train them with this new funding source. That was also really no funding for Bigelow to be able to do that work. So we would go up when we had, the ability, when they requested us to go up, that was a 3-hour drive north to be able to get there. We would go and we would do this research with them based on their needs. And that's a lot of students to take into, in and around in a small community. So I would say if every time we go up several times a year, we get 5 to 8 students, that's a pretty big impact. And that research has grown because now we're advertising for undergraduate students to come work with the Zabaic Environmental Department in their community, and then come to Bigelow to learn the skills during the summer. So we are training and giving back, and that is because the ties for the Passamaquoddy tribe and many tribal nations is to be in that community and work for that community. And if we can start to do that from middle school, high school, and undergrad, then that gives us a pipeline of expertise that they won't. Our goal is to work ourselves out of a job, right? Is that if you can train them well enough to do the things that they know they need to do, eventually they'll take over those skills, and there is no bigger compliment. It's like us with our students and postdocs, right? The best compliment is they do a successful job moving forward. There are plenty of groups that want support. And even with the PFAS, there's going to be training of how to do the first steps of that process to do that quantification. The rest will have to be done at Bigelow with our instrumentation, but we don't have to do it all. And the ability to communicate back to community when the people who are on the ground have done it with their own hands, that see how long that process takes or how to understand the data, that's invaluable. Those are people talking to their neighbors and saying, why are you collecting this sample? I know exactly where that sample goes, whose hands it goes into, what instrument it goes into, and what data we get back, and I know we can trust it because I did it myself. And I think that's really important.
Any further questions? Okay, I don't see any. Thank you very much, Rachel.
Thanks.
And there's a little bit for you. Thank you. Thank you very much for joining us at the Sunset Lecture. Have a very good evening, and for those of you that are here at the conference, enjoy Makanda. Thank you. Bye.